You are now seeing the locations of all the impact craters appearing on the world map, of meteorites, asteroids, and comets clearly identified on the surface of our planet. Each circle represents an event of extreme violence, and the larger they are, the more phenomenal the energy released was. Today, I'm taking you on a trip around the world to discover the scars of our planet, which were carved out by pieces of the sky that fell on its head. Objects of rock, ice, and metal, which, by hitting us faster than a rifle bullet, left impressive marks in the ground that tell us a terrible story. Among the nearly 200 known impact craters, we'll focus on the best preserved and most spectacular. Starting with the smallest ones, which would only be dangerous for you if they landed in your backyard or in the neighboring city, gradually moving towards those that the Earth will never forget, and that could make you regret being born, even if they were to crash in another country or on another continent. And now, let's get back to our impact craters, starting with one of the most recent and also one of the smallest that we know of, the one in Caracas. Which, 13 meters wide and 5 meters deep, was formed in Peru in 2007 by the impact, in the clay soil by a meteorite barely half a meter wide. This type of small crater is surprisingly rare, because even though it's estimated that about 20 meteorites capable of making such holes hit our planet every year, most of them break up in flight and are pulverized in the atmosphere by friction long before reaching the surface. And most of those that do make it hit the oceans or are never found because they fall in uninhabited areas. So it is believed that all in all, only a few craters like Caracas are formed per century. Now let's head to the largest island in Estonia, where you can literally walk through the 8 craters of Kali. All of which were formed more than 5,000 years ago, by the arrival of an object estimated to weigh about 50 tons. It broke into several pieces a few kilometers above the ground, landing as multiple fragments. The largest created a 110-meter wide, 22-meter deep crater. If these craters seem small, consider that the impacts that formed them propelled nearly 80,000 cubic meters of molten rock several kilometers into the air, while instantly burning vegetation within a 6-kilometer radius. Meanwhile, the vibrations of the Earth's crust triggered a tsunami in the Baltic Sea, the traces of which have been found as far as Sweden. It's important to keep in mind that none of the craters we're going to see today is just a simple hole, because at the point of impact, the pressure exceeds that at the center of the Earth. The rocks at the front in the ground don't absorb the shock. Heat causes them to become vitrified, vaporized, and expelled as molten or plasma in all directions. In the south of Algeria, in the harshness of the Sahara, lies the Amguin impact crater. This is only about 100,000 years old. It means that humans may have seen the meteorite that formed it tear through the sky as it passed, before crashing down with an apocalyptic screech. Even if the impactor was, as almost always, completely pulverized, we know that, generally speaking, the dimensions of a crater are 20 times wider than the object that hit the ground. To create a hole 550 meters wide and 65 meters deep like this crater, it took a meteorite barely about 30 meters in diameter to reach the ground. Almost twice the size of Amgued's, the remarkable Wolf Creek crater is found in northern Australia. Which is 900 meters wide and 60 meters deep. It was violently formed about 300,000 years ago, when the first sapiens were just beginning to roam Africa. And none of them were present in Australia yet to witness the fall of a meteorite about 40 meters in diameter. And to enter the category of craters more than a kilometer wide, we're going to focus on the very photogenic and famous Meteor crater. Lost in the sands of Arizona, this scar measuring 1.2 kilometers in diameter and 180 meters deep has been thoroughly studied from every angle. Today, we know that this crater, which owes its slightly square shape to the presence of fractures that channeled the direction of compression during the impact, was formed 49,000 years ago by a projectile 50 meters in diameter, made of a mixture of iron and nickel and roughly as dense as an anvil. When it hit our planet at nearly 15 kilometers per second, 150 times faster than a high-speed train, the meteorite that formed Meteor crater, weighing as much as 30 Eiffel Towers, unleashed energy equal to 2,000 Beirut port explosions. Or, if you prefer, 150 times that of the Hiroshima bomb. This immense energy, released in an instant, ripped 175 million tons of rock from the ground, some as large as small houses. They were scattered in all directions across an area 2.5 times larger than Paris. We've now entered the realm of city destroyers. What if a meteorite like this hit Paris today? The heat, and especially the shockwave, moving at a speed of 2,000 kilometers per hour, would practically flatten all the buildings, killing almost all the inhabitants instantly, within 4 kilometers of the impact point. Luckily, this type of event happens about once every 1,000 years on average. And above all, the Earth is vast, so in the vast majority of cases, meteorites fall into the oceans or in uninhabited regions. Yet, as impressive as it is, the Meteor crater is the result of a large-scale impact. It's like a fly's fart compared to the Ariane rocket's engine. Slightly larger and therefore slightly rarer in terms of frequency than the Meteor, we find in India, about 400 kilometers northeast of Mumbai, the Lona crater. Aged 52,000 years, its 800-meter width is known for hosting a lake, which can exceptionally change color and turn pink. A significant drop in water level and rising salinity encourage bacteria that create a red pigment. Now let's head to Mauritania to discover, isolated deep in the Sahara Desert, the Tenyouma crater, one of the planet's best preserved impact craters, just 20,000 years old. A structure almost 2 kilometers wide, with edges over 100 meters high, above the surrounding desert plains. It was long mistaken for the eroded summit of an ancient volcano. But the mineral changes at the impact site and the discovery of tektite. These tear-shaped, glassy stones, formed by drops of molten rock that, after being ejected into the atmosphere, can fall back to Earth dozens or even hundreds of kilometers away, leave no doubt as to the origin of this crater. Almost 6,000 kilometers away in the Namib Desert, a crater just larger than Tenoumer stands out from the Red Desert. Although nearly 5 million years old, the Rotterdam crater, with its 2.5 kilometers in width and 130 meters in depth, still hasn't been erased by the movement of the dunes and wind erosion. This gives us a small idea of the energy that carved it out. With this type of object, we're in the category of those that could easily devastate an entire region. Lost in the vast expanses of northeastern Canada lies the Pingualiot crater, Quebec's smallest of 8 known meteorite impact craters. Formed only 1.4 million years ago, it now contains a circular lake 3.5 kilometers wide. Named the Crystal Eye, this lake, which makes the crater easily visible from the sky, is fed only by rainwater. So it is estimated that it took nearly 3 centuries of rainfall to fill it completely. In northwestern Algeria, across the Atlantic, there's another impact structure visible from space. Also large, about 3.5 kilometers wide, the Walkes's impact crater was formed by a rocky meteorite, which must have been about 150 meters in diameter. A meteorite large enough to cause such a significant regional impact is estimated to enter Earth's atmosphere about every 15,000 years. But since many of these craters are quickly covered by tectonic plate movement or by sediments, not all of them have been discovered yet. Here in northwestern Australia, this bowl-shaped depression is actually a 5-kilometer wide impact crater that formed 50 million years ago. Once over 200 meters deep, it is now nearly filled by erosion of its sides. Now, let's head to the other side of the planet to explore the Gog crater. Heavily eroded and shaped by the ice cap that, for thousands of years, towered over it. This 5-kilometer wide crater contains a lake surrounding a central island formed by material from the ground, which, under the force of the impact, bounced back. Like a gigantic drop of molten rockwood concentrating some of the material in the center. And from now on, the craters we will fly over, formed by ever greater amounts of energy, will have increasingly complex shapes. As the Tindida crater demonstrates, located in the province of Tamanrasset in southern Algeria. At 6 kilometers in diameter, it has the unusual feature of being made up of striking ridges and folds. Practically concentric, they were formed by the erosion of older rocks, which were less resistant to the ravages of time. About 15,000 kilometers away in Australia is the Pincanini crater. The oldest of all those we have flown over so far. This image shows 360 million years of erosion, and they weren't enough to completely erase the traces of an impact involving an object 350 meters wide. And even though the edges of the crater have long since been erased and the hole created by the arrival of the meteorite, which was originally 500 meters deep, has been completely filled in, the shape of the crater is still clearly visible, because the rocks that were altered by the impact have withstood the passage of time differently. In Australia, within the vast Gibson Desert, there is a 9-kilometer wide impact crater. It's known for the streaks left by streams that occasionally run down its sides. And its circular structure has remained well preserved despite being 60 million years old. On the other side of the world, we find the Vista Alegre impact crater in Brazil. Its circular depression, though similar in size and age, fails to stand out from its surroundings. To find a 10-kilometer wide impact structure still visible after 170 million years, head to Utah's impressive Oophival Dome. This intimidating geological structure is a crater formed by a series of concentric rings created by the impact of a body that was most likely about 500 meters in diameter. To try to get a sense of the effects that a meteorite impact like the one that created this crater would have today, let's cross the Atlantic Ocean to go to Ghana, where, near the large city of Kumasi, lies the impressive Bosumtwi crater, which now holds a lake nearly twice as large as Lake Annecy. The Bosumtwi crater is both the largest of the recent craters, since it is only 1 million years old, but it's also one of the few impact craters identified in the intertropical zone. Measuring 10.5 kilometer wide and 500 meters deep, it was also formed by a meteorite at least 500 meters in diameter. And clearly, with this type of impact, we're in the category of those that could easily devastate an entire country. To convince you, just imagine if a meteorite like the one that created the Bosumtwi crater were to fall in the same place again. Today, practically all living beings located within 100 kilometers of the impact point would be almost instantly incinerated by the radiation alone from the resulting fireball and plasma. If it helps, such objects enter our atmosphere only about once every 150,000 years on average, which is not reassuring. Just to cool us down a bit, let's head north in Quebec to find, about 200 kilometers from the Pingualyot crater, the Couture crater. Estimated to be 430 million years old, and it is so wide and deep that it's the only lake in the region that can remain ice-free during the winter. One of the best preserved impact structures on our planet, and without a doubt, the very hard-to-reach Tauranga crater. Located in the Chadian Desert and easily visible from space, these successions of concentric rings, 16 km wide, were produced by a vertical impact estimated to have occurred 345 million years ago. The astonishing parallel lines that surround and partially cover the crater are yardangs, rocky ridges shaped by the wind, which in this region almost continuously blows from the northeast toward the southwest. We have now definitely entered the category of craters whose dimensions are too vast to be taken in at a single glance from the ground. In northern Australia, you can see this from both an airplane and the space station. International, a part of the Gosbluff crater. As impressive as these circular mountain chain-shaped formations are, spanning 5 kilometers wide, they are only the visible part of a much larger crater, the eroded remnant of the central uplift formed after the impact, while the outer edges of the original crater, which was 22 kilometers in diameter, have been completely erased by 140 million years of erosion. In the Canadian Arctic, on Yvonne Island, there is an impressive 23-kilometer wide impact crater. Created by a meteorite over 1 kilometer wide about 39 million years ago. If a meteorite like the one that created the Octone crater fell in the same spot today, it would directly kill only about 100 people. Because Yvonne Island is the largest uninhabited island on our planet, and it is located in one of the least populated regions in the world. On the other hand, if the same object struck a densely populated region of the globe, it would almost instantly kill tens of millions of people. Just to keep climbing up the list of craters we wouldn't want to see form, even on enemy territory. Next, let's head to Germany to discover the Ries crater. Today, at the center of a 25-kilometer wide depression, it is home to the medieval town of Nordingen. Here, impact evidence isn't immediately clear. Studying the stones and their shapes revealed events from about 15 million years ago. An asteroid more than a kilometer in diameter crashed into this region at a speed of 20 kilometers per second. If such an event happened today, you would be well advised not to live in Europe. Here, all around the crater, which has been largely erased by the lakes that have formed there over time. In the sediments, over dozens of kilometers around, we find layers of melted rocks, torn from the Earth's crust by the power of the impact. In some places, the landscape was literally buried by the collapse of a cloud of incandescent material. We also find, embedded in the rocks of this region, microscopic diamonds that were produced by the temperature and pressure of the impact. Too diluted in the rocks to be exploited, they still exist in nearly all the old stone buildings in the city. Slightly larger than the Reyes crater, the Shoemaker Impact crater, located in Australia. What is special about this is that these 30 kilometers in diameter are partially occupied by seasonal salt lakes whose colors give the region an unreal appearance. This crater, dated to about 1.6 billion years ago, is one of the oldest ever found on the surface of the Earth. On the other side of the world, in northwestern Greenland, under the Yawata Glacier, thanks to radar surveys, an impact crater was found that is comparable in size to the Shoemaker crater. And inside it, you could easily fit Washington, District of Columbia, or Paris. Sediment samples taken from the main river flowing under the glacier showed that this crater buried under nearly a kilometer of ice, was most likely formed by the impact of an iron asteroid more than a kilometer wide. Thousands of kilometers away in Quebec, there's an amazing double impact system clearly visible from space. It is believed that these two craters, now occupied by the Clearwater Lakes and measuring 26 and 36 kilometers wide respectively, were formed 280 million years ago by a binary asteroid, meaning two bodies, gravitationally bound and sharing a common fate. Thus, this astonishing doublet would have been formed by a pair of asteroids that crashed almost at the same place and at the same time on the surface of our planet. Let's now head off the coast of Norway, in the Barents Sea, where the Bjolnir crater is located. If you don't see anything, it's because it's underwater. And even though it has been completely buried over time under hundreds of meters of sediment, its 40-kilometer diameter is still visible in deep seismic survey imagery. What if a 2-kilometer wide bolide were to impact our planet at the exact spot where Bjolnir was formed? This would result in a deluge of waves several hundred meters high crashing into northern Scandinavia within half an hour of the impact. Recently, Swedish geologists even discovered evidence of a giant tsunami that impacted most of what would later become this region of the world. It dates back about 145 million years, the supposed age of Bjolnir. Still in Scandinavia, nearly 2,000 kilometers from there, is the largest known impact crater in Europe, the Siljan crater. A part of the depression, which is 52 kilometers wide, is now partially filled with water. This crater was formed about 400 million years ago, at a time when no form of life had yet evolved on the surface of the continents. If such an impact were to occur today, it would probably annihilate all forms of life in Northern Europe. Impacts of this magnitude, with absolutely catastrophic consequences on a continental scale, occur on average every 15 million years. And currently, we know of only 15 craters, whose dimensions are greater than those of Siljan. You can see the impact points gradually appear on the map. I won't go through all of them, since most, being very old, have been visually erased by time. So their existence only becomes obvious when you look closely at the nature and orientation of the underground rocks. But to try to get a sense of the effects produced by such monsters, let's focus on one of the most studied events, the one that created the Charlevoix impact crater in Quebec. Only half of this 54-kilometer wide, 450 million year old crater is still visible on the surface today, because it was split in two by the St. Lawrence Fault, and the rest is partly buried beneath the surface. In Charlevoix, one of the most impressive traces left by the impact can be seen at eye level, and surely the presence of these impressive rocks called shattercones, whose structure and orientation point toward the impact site. These unusual rocks formed from a shock wave that moved supersonically through Earth's crust, by subjecting the material it encountered to a pressure momentarily greater than that which currently exists at the center of the Earth. Researchers modeled and recreated the catastrophe scenario by studying the region's geological structures. An opportunity to pause and relive the unreal violence of such an impact. To give you an idea of the asteroid that created the Charlevoix crater, imagine a block made of rock and metal the size of a mountain, and moving at 20 kilometers per second, a speed so fast that just over 5 seconds passed between its entry into the atmosphere and the moment the asteroid struck the Canadian Shield at 72,000 kilometers per hour. In a fraction of a second, the entire impactor was vaporized, releasing an amount of energy equivalent to the simultaneous explosion of 50 million conventional atomic bombs. At the point of impact, several trillion tons of rock are torn from the Earth's crust. Liquefied and vaporized, the incandescent matter rises into the sky, forming a plasma ball hotter than the surface of the sun. and overlooking a gaping hole 10 kilometers deep, which in just a few minutes is almost completely filled by a deluge of molten rock falling back from the sky. At 100 kilometers from ground zero, which is where the city of Quebec is today, the plasma ball is 2,000 times brighter than the sun. Even when observed from the position of Montreal, which is 400 kilometers from the impact point, the plasma ball still shines with the intensity of 100 suns combined. In fact, the radiation emitted by this event alone is so powerful that all plants directly exposed to it catch fire, within a radius of 400 kilometers around the point of impact. 3 minutes later, molten rocks pour from the sky. And the region where the city of Quebec is today is buried under 15 meters of debris before a wall of burning air arrives. A shockwave moving at over 2,000 kilometers per hour, a speed fast enough to shatter buildings as solid as bunkers. 300 kilometers away, near Montreal, wind speed remains close to 1,000 kilometers per hour. All unburned trees within 850 kilometers of the impact point are knocked down. And we're only talking about the 15th impact, the most violent one, found on Earth's surface. To see for ourselves, let's head north to discover, 500 kilometers from the Charlevoix crater, the Manicouagan crater, also called the Eye of Quebec. Formed 214 million years ago, this massive scar is a favorite of astronauts who enjoy photographing its nearly perfect ring from space. And with it, we move from continental repercussions to those of a global scale. This kind of impact is not something you'd want to witness in your lifetime, even on the other side of the planet. The Manicouagan crater, which is the 6th largest confirmed impact structure on our planet, is only twice as wide as the Charlevoix crater. So you might imagine that the amount of energy released here was roughly twice as great. Except that a crater twice as large actually means the energy released on impact was about 100 times greater. Now, imagine you're on vacation somewhere around here, enjoying the view of one of the largest lake islands in the world, which was formed by the central uplift after the impact and is now surrounded by a huge lake created by dams. Suddenly you're told that in 7 hours an asteroid the size of the one that created this crater is approaching. A block larger than Mont Blanc is going to hit precisely the location of the Manicouagan crater. Without waiting a second, you jump into your car and drive as fast as you can heading south. 7 hours later, and just as you arrive in Quebec City, 800 kilometers from the impact point, the asteroid hits. 800 kilometers might seem like a safe distance to you, except that in the case of Manicouagan, the effects felt at such a distance would be almost identical to those experienced by Quebec City itself. In the case of Charlevoix, the distance from the impact point here is 9 times greater. In addition to Manicouagan, there are 2 other known impact craters on a global scale, each with a diameter of about 100 kilometers. The Acraman crater in Australia is less than 580 million years old. And the Popigai crater, discovered in the far north of Siberia, which was formed 36 million years ago. This makes it the last planet-wide impact to have shaken the Earth. But what makes the Popigai crater particularly interesting is that it contains hundreds of trillions of diamonds that were formed by the impact. Because the asteroid that created this crater struck the Earth's crust at a spot where layers of limestone rocks rich in graphite were stacked. 12 kilometers from the impact, within a dense shell 1 kilometer thick. The conditions were right for the phenomenal pressure to shock the atomic arrangements of carbon and transform some of the graphite into diamond. So here you can find several micrograms of precious stones per cubic meter of rock. It is estimated that the Popigai crater contains a total of 10 million tons of diamonds. That's nearly 10 times the estimated amount of all other known reserves on the planet. Today, the crater is not being mined because the diamonds found there are about the size of grains of sand, which is only of interest to industry and not to jewelry. And especially because Russia, which already produces synthetic microdiamonds, doesn't want to tap into this resource. We are now at the foot of the podium, craters over 100 kilons. On Earth, only 3 known impact craters have a diameter of about 200 kilometers or more. And with these, we are undoubtedly entering the very exclusive realm of large-scale extinction. It is believed that impacts capable of having such consequences occur every 100 to 200 million years on average. The first of these is by far the most well-known of all, since it played a part in wiping out the dinosaurs 66 million years ago. This 170-kilometer wide crater named Chicxulub, and whose dimensions you can see in the image, has long since disappeared from the surface. And it wasn't until the 1980s that it was finally discovered. Buried under thick layers of sediment and partially submerged by the sea at the Yucatan Peninsula in Mexico, the existence of this crater was strongly suspected before it was actually found. After it was discovered in the rocks that formed at the time when the dinosaurs disappeared. Abnormally high levels of iridium, an element typically found only in trace amounts in Earth's crust, but is more common in asteroids and comets. It was only after several drillings in this area that a large amount of quartz was found. Shocked with high-pressure impact breccias and minerals, this unusual structure was discovered. The Chicxulub crater, which is 170 kilometers wide, was most likely formed by the impact of an asteroid 10 to 12 kilometers in diameter that struck the Earth at a speed of about 20 kilometers per second, releasing almost instantly as much energy as several billion atomic bombs combined. Since the consequences of such an impact warrant their own episode, I won't go into detail. Just keep in mind that the event hurled gigantic blocks of molten rock thousands of kilometers away, like many secondary impacts, while encircling nearly the entire planet, with a blanket of burning ash that indirectly triggered giant fires on almost every continent. 5,000 kilometers away, in Canada, in northeastern Ontario, is the second largest known impact crater on Earth. Because the Sudbury Basin that you see in the image, which is 60 kilometers wide, is only a small part still visible on the surface of the crater with the same name. Its original size was about 250 kilometers in diameter, and it has been heavily deformed and eroded by the force of geological processes. The fact that traces of an event that happened 1.8 billion years ago can still be preserved in the rocks today gives you an idea of the violence of the phenomenon. Here, the cosmic impact not only turned the Earth's surface into hell, but also forged an underground treasure. Because by melting the Earth's crust, the impactor, nearly 15 kilometers in diameter, created an ocean of magma 2,000 meters thick. Acting like a huge settling cauldron, this short-lived ocean of molten rock allowed the densest metals to sink to the bottom and seep into the surrounding fractures. Thus, once the magma cooled, it gave rise to veins extraordinarily rich in metals. And that's why the Sudbury Basin is today a unique metal deposit in the world. About 15 active mines here extract high concentrations of nickel, copper, cobalt, iron, gold, platinum, and palladium. The gold medal goes to Vredefort. This crater, located in South Africa, is both one of the oldest and the most impressive impact structure visible on the surface of our planet. And this, even though it is 2 billion years old and also largely eroded. Look at this ring of hills with folded layers visible from space. This is only a third of the central uplift dome, which alone is already almost the size of the Charlevoix crater. Considering the buried and eroded sections, the Vredefort crater's original diameter is estimated at 300 kilometers. That's almost double the size of the Chicxulub crater. Just like the Sudbury impact, the Vredefort impact left behind the seeds for the birth of a treasure, by making resources usable that without it would have remained inaccessible. Today, the basin that partially surrounds the Vredefort dome is the world's main gold-bearing deposit. Nearly 30% of all gold ever mined comes from this region because the impact shattered the continental crust and injected massive energy. The impact acted like a washing machine, dissolving precious metals and concentrating them in fractures. Today, miners follow the direction of the veins to recover the treasure. The Vredefort crater formed 2 billion years ago, at a time when all living beings were still underwater and our planet did not yet host any complex forms of life. But there is no doubt that the primitive inhabitants of those distant times felt its effects. Now let's go back for a few seconds to our starting map. I think you may have noticed that in the distribution of these nearly 200 impact craters, there's something a bit strange. Many of them seem to be concentrated in just a few regions of the globe. In fact, if North America, Scandinavia, and Australia are so richly endowed with craters, it's for 3 reasons. These regions have been explored most thoroughly. Next, they are far enough from the equator that craters there are not quickly buried and erased by intense biological activity, which almost everywhere settle in their hollows, cover, conceal, and hide them. And most importantly, these regions consist mainly of ancient bedrock. On this map, you can see the oldest regions of our planet shown in orange, which have not been transformed recently by tectonic plate movement, volcanic activity, or mountain formation. And you can see that these portions of continents, which we call shields, are also the areas where the most impact craters have been found, with the notable exception of Greenland, where almost all the craters are hidden from us by the polar ice cap. As for the almost complete lack of crater discoveries on the ocean floor, it's mainly because the great depths are difficult to access. Everything there is quickly covered by a thick layer of marine sediments, and the oceanic plates are renewed much more quickly than the continental plates. Yet, when looking at this map, on which the locations of all objects measuring from 1 to 20 meters whose disintegration has been identified are grouped together, between 1994 and 2013, meteorites in our upper atmosphere arrived from all directions, with no clear preference. In short, Earth is extremely good at healing itself, with only 200 visible impact craters today, over nearly 4.5 billion years of existence. On the Moon's surface, which has no atmosphere, life, or tectonic activity, its wounds rarely heal. No fewer than 300,000 craters over a kilometer wide. Here, you'll find a playlist that takes you on a journey to discover extraordinary and too often forgotten landscapes from our planet's past.